Let's take a look at another functional equations. So this one is from the USA Mathematical Olympiad 2002. So it says find all functions f from real number to real number which satisfy the equality f of x squared minus y squared equals x times f of x minus y times f of y. So first of all, we will try to substitute x equals y equals 0. So it becomes f of 0 square minus 0 square equals 0 times f of 0 minus 0 times f of 0. So the right side becomes 0 and the left side is nothing but f of 0 equals 0. So this is the first step. We will try to evaluate some simple number like f of 0, f of 1 or whatever. So next we will try to, from the original equation we substitute y equals 0. So that on the left side we have a f of x squared minus 0 squared equals x times f of x minus 0 times f of 0. So it becomes f of x squared equals x times f of x. We may call this one equation 1. So by making use of this equation, we can have f of x squared equals f of minus x squared, something like this. So actually they should be the same because minus x squared is x squared. So we can make use of the equation 1 so that on the left side it is nothing but x times f of x. And on the right side, we substitute x by minus x. So it becomes minus x times f of minus x for all x is a real number. Which means that other than x is 0, then we can just eliminate x on both sides, so that we know that f of minus x equals minus f of x, which means that f is an odd function. So next, we can go back to the original equation, and then we can make use of equation 1 to do something on the right hand side. So on the left hand side it is still the same, f of x squared minus y squared, and then making use of equation 1, we can replace x times f of x by f of x squared. And similarly, we can replace y times f of y by f of y squared. These two depends on equation 1. So we can slightly rearrange the term like f of x squared equals f of x squared minus y squared plus f of y squared, which means we just move f of y squared to the left side and then swap the left and right. So now we can so up till now we know that x is for any arbitrary real number x, y, both x and y. So now we can make a substitution as x to be let me see, a plus b, and take the square root of the whole term. And then for y, we take it to be square root of b. For this case, a and b are positive or non-negative real number. Maybe positive is quite enough because we already show that f of 0 is 0. So we substitute these two into equation 2. So we will have on the left side f of square root of a plus b squared, which is f of a plus b, and then equals f of x squared is a plus b, y squared is b, so that x squared minus y squared is a, and then f of y squared is f of b. So substitute into the original equation, so we can get this one. For x, y are positive real number, but we know that f is odd. F is odd, which means that for f of minus a plus minus b is f of minus a plus b. So we make use of the odd property. So we have minus f of a plus b. And then we can make use of this 3. So make use of 3. We can have minus f of a plus f of b. And then we can again make use of the odd property, so that minus f of a is f of minus a plus f of minus b, which means that for negative real number, for this case we only make use of equation 3 for positive real number. But here we show that equation 3 is also good for negative real number. So that's f of a plus b equals f of a plus f of b, which is such for all a, b are real number. So next, so up till now we know that this is actually the Cauchy equation. The Cauchy equation, which means that from the original functional equation, we can actually derive the Cauchy equation. But the original equation is not limited to the Cauchy equation, because if we only have the Cauchy equation, we still need some other condition like continuity or monotonicity, etc., to have the solution to be f of x to be f of 1 times x for all real number. If we don't have the continuity, monotonicity, we can only come up with this solution for rational number. But actually we can still make use of the original equation, or not rigorously writing, we can write it as, if we have the original equation minus the Cauchy equation is not nothing. It's not nothing. We still have something left. So from the original equation, we can substitute x to be 2t plus 1, and then y by 2t, and t for all t is a real number. So in this case, we have f of 2t plus 1 square minus 2t square equals 2t plus 1 times f of 2t plus 1 minus 2t times f of 2t. Actually, for the original for the equation 3, we can also show that for equation 3 we can also show that by letting b equals a, then we can have f of 2a equals 2 times f of a. 2 times f of a. Or actually we can go for it further, like f of n times a equals n times f of a, for n is a positive integer. So on the left side, this is 4t squared plus 4t plus 1 minus 4t squared. So that 4t squared and 4t squared can be cancelled. So it becomes 40 plus 1. And in equation 3, so in equation 3, we can make a to be 40, b to be 1, so that we will have f of 40 plus f of 1. And further, we can have f of 40 equals to 4 times f of t plus f of 1. So on this side, we have this expression. So similarly, f of 2t plus 1 would be f of 2 times f of t plus f of 1. Similar to the left side. And then this is 2t plus 1. And then minus, for this one, it is 2t times 2 times f of t. So we have 4t times f of t, and then plus 2 times f of t, plus 2t f of 1 plus f of 1 minus 4t f of t. 4t f of t. So in this case, 4t f of t and 4t f of t can be cancelled. F of 1 and f of 1 can be cancelled. And then still, this 4 times f of t and 2 times f of t can partially cancel, so that we have 2 times f of t on the left side. So this one is already cancelled. So finally, on the right hand side, we will have 2 times t times f of 1 and nothing remaining. So finally, we can further cancel this 2 and this 2. And finally, we will have f of t equals t times f of 1 for all t is real number. Or you can write it as f of x equals x times f of 1 for all x is real number. So we can have a simple check. F of x squared minus y squared equals x times f of x minus y times f of y. So for the left hand side, f of x squared minus y squared is nothing but x squared minus y squared times f of 1. So this equals x times f of 1 times x. So we just split the x squared into x times x, and 1 put in the front and 1 put in the back, and then we just have a bracket here. So minus y times f of 1 times y. So this one is nothing but f of x. So f of x times x is x times f of x minus y times f of y. So which is actually the right hand side. So this is the end of this video.